A famous pair of Harvard studies, which involve so many people over so long a time, they've by now chalked up millions of person-years of data, found that the consumption of anthocyanin-rich foods containing those bright-colored plant pigments, was associated with a lower risk of developing type 2 diabetes over time, particularly blueberries. Just 2 or 3 servings a week associated with a 23% lower risk. In my daily dozen, I recommend berries every day. Why, though? What do berries have to do with diabetes? Well, type 2 diabetes is caused by insulin resistance, and interventional studies evidently clearly show that dietary berries can ameliorate insulin resistance. Yeah, but that was in diabetic mice. What about in men and women? Those consuming lots of anthocyanin-rich foods like berries didn't just have less inflammation, but significantly lower insulin resistance. OK, but by how much? By as much as you would get walking like an hour a day, 7 days a week. Wow, how many berries were they eating? That was for 35 milligrams of anthocyanins a day, so like a cup of strawberries or cherries, a half cup of raspberries, or just a quarter cup of blackberries, or even just a few spoonfuls of blueberries. But that was just a snapshot in time cross-sectional study. What we need are interventional trials, where you give people blueberries in a double-blind, randomized, and placebo-controlled clinical trial to truly put them to the test. OK, here you go. So they could fake people out with a placebo, they used powdered blueberries, the equivalent of about 2 cups of fresh blueberries worth in a smoothie, and got a significant improvement in insulin sensitivity. 2 cups is a lot, though. Any benefits for just a typical half-cup serving? This study demonstrated a significant reduction in postprandial oxidation, meaning all the free radicals created when you eat some sugary breakfast like cornflakes. Here's the antioxidant capacity of your bloodstream, taking a nosedive 2 hours afterwards as your body tries to cope. But eat it with a half cup of blueberries, and you start out higher and stay higher after the meal. Note they also tried just adding a quarter cup of blueberries, and that was clearly not enough, so we should strive for a full serving. The reason we care about free radicals, though, is that they can damage our DNA. Can a single portion of blueberries really improve protection against DNA damage? A single portion of blueberries can improve protection against DNA damage. They drew blood from people before and after they ate some frozen blueberries, and exposed their white blood cells to free radicals in the form of hydrogen peroxide. And blueberries significantly reduced the DNA damage done within a single hour after berry consumption. However, the protective effect was transient, and our DNA vulnerability returned within 2 hours. So we want to be eating super healthy foods like berries at every meal. In conclusion, 1 portion of blueberries can improve our cellular resistance to DNA damage, thus supporting the importance of consuming healthy plant foods regularly. Studies comparing country-by-country cancer rates have shown up to a 70-fold variation in the incidence of prostate cancer worldwide, with low rates in parts of Asia and Africa, and high rates in North America, Australia, New Zealand, and Northern Europe. Here's the map of prostate cancer mortality. Could dairy consumption have something to do with it, given Northern Europeans, Americans, Australians drink a lot of milk, whereas most non-Caucasians in the world are lactose intolerant? But just because a country drinks a lot of milk and has a lot of cancer doesn't mean the individuals within that country that are drinking the milk are getting the cancer. That's why we need cohort studies, where you find out how much milk people drink and follow those individuals over time, and see if those who drink more milk get more cancer. There have been dozens of such studies done. Put them all together, and intakes of total dairy products, including low-fat milk, were indeed associated with increased prostate cancer risk. The question is, Why? Maybe it's just all the calcium? They found that the more calcium people consume, the higher their risk of prostate cancer. Yeah, but most people get their calcium from dairy, so how do we know this isn't just a dairy effect? Before we start worrying about kale and other non-dairy sources of calcium, it'd be nice to see dairy calcium teased out from non-dairy calcium intakes, and that's exactly what they did. Yes, the more calcium from dairy sources, the higher the risk of cancer, but non-dairy sources of calcium were found to be protective. So it wasn't a calcium effect, it was a dairy effect. This suggests that other components of dairy may be to blame. They suggest it's the animal protein boosting the levels of a cancer-promoting growth hormone called IGF-1, insulin-like growth factor 1. If you look at 28 studies involving nearly 28,000 people, this is what's called an albatross plot. Any study to the right of this line shows a link between IGF-1 levels and dairy product, milk specifically, or dairy protein consumption, and any study hitting this line or over shows a significant association with higher IGF-1 levels. This could also explain why plant-based diets can be so protective. Put watch and wait cancer patients on a whole food plant-based diet for a year, no chemo, no radiation, lifestyle changes only, and get a significant reduction in PSA levels, indicative of tumor shrinkage, their bloodstream becoming nearly 8 times better at suppressing the growth of cancer cells. Do biopsies, and you can show changes in gene expression, a downregulation of critical cancer genes, effectively switching off cancer growth genes at a genetic level. Whereas if you instead eat lots of dairy after a prostate cancer diagnosis, you may suffer a 76% higher risk of death overall, and a 141% increased risk of dying specifically from your cancer. Even without IGF-1, the milk protein casein appears to be a cancer cell proliferation promoting factor, increasing the growth of prostate cancer cells, at least in a petri dish, and the same thing with whey, the other major animal protein in dairy. See, nearly 100% of advanced prostate cancers thrive by upregulating a growth enzyme called TOR, and dairy protein boosts TOR signaling even higher, which only makes sense, right? Calves have to grow like 40 times faster than human babies, and so cow's milk has to be packed with growth promoters, not to mention the hormones in milk, especially from cows who are already pregnant again. This commercialized milk production by pregnant cows releases uncontrolled amounts of bovine steroid hormones into the human food chain, and so the combination may well explain the observed association between high dairy consumption and increased risk of prostate cancer. From an evolutionary perspective, the persistent abuse of the growth-promoting signaling system of bovine milk by humans over their entire lifespan, not just drinking milk during infancy, maintains the most important hallmark of cancer biology, this sustained proliferative signaling to grow, grow, grow. And so there's this interest in trying to define the safe upper limits of long-term milk and dairy intake for the prevention of the most common dairy-promoted cancer in men. But if you look at diet and cancer guideline recommendations, yeah, milk may increase risk of prostate cancer. However, no recommendation was provided for cutting down on dairy, because the evidence for prostate cancer conflicted with decreased risk of colorectal cancer. High dairy intake is associated with increased prostate cancer risk, but decreased colon cancer risk. So it's like, alcohol may be an intoxicating carcinogen, but policymakers hesitate to introduce effective alcohol policies, or even to support the addition of cancer warning labels for fear they might undermine any possible health benefits of alcohol use. Now, I've talked about how the purported benefits of alcohol appear to be evaporating. Is dairy really protective against colon cancer? If you put all the cohort studies together, where they measured dairy consumption, then followed people for years to see who got cancer, milk and total dairy consumption was indeed associated with a reduction in colorectal cancer risk, one of our deadliest cancers. Now, people who drink more milk just happen to tend to exercise more, smoke less, drink less, eat less meat, which could explain some of the association. However, many of the studies adjusted for these kinds of confounding factors. More likely, it was the protective effects of the calcium, which may bind up pro-inflammatory bile acids in the gut, though high-fat dairy products like cheese may actually increase bile acids, explaining why the cheese appeared to cancel out the calcium benefit. So might we be able to get the best of both worlds by consuming non-dairy calcium sources? If you randomize people to calcium supplements, you can get a significant reduction in recurring colon polyps, which can otherwise turn into cancer, though calcium pills have been associated with adverse cardiovascular effects. And so the best of all worlds, if you want to take a precautionary approach in terms of nutrition and cancer, is to obtain calcium through low-oxalate, dark green leafy vegetables, beans, split peas, chickpeas, and lentils, or, if necessary, calcium-fortified foods such as soy or almond milk. California was the first state to legalize medical marijuana. When labs started reporting that they were finding high levels of pesticide residues, the LA City government covertly acquired and then tested 3 samples from dispensaries and found that 2 of the 3 samples did have exceedingly high pesticide levels, up to 1,000 times the legal limit. Yeah, but how much ends up inside the consumer? Only about 10% or so of pesticides in tobacco makes it through a filtered cigarette, which was found to be comparable to using cannabis in a water pipe with filters attached. But use a regular bong, and about half the pesticides end up in your lungs, and a glass pipe is even worse. Because most users don't attach a carbon filter to their bongs with 7.5 grams of activated charcoal, in general the portion of pesticide recovery from cannabis would be alarmingly high and is a serious concern. Although we don't know precisely how damaging these chemicals are, the fact that they're present in smoke at such high levels should be concerning. Considering these results, high pesticide exposure through cannabis smoking is a significant possibility, which may lead to further health complications in cannabis consumers, especially if we're talking about medical marijuana, sick, vulnerable people, potentially making things worse. The potential of pesticide and chemical residue exposure to cannabis users is substantial, and may pose a significant toxicological threat in the absence of adequate regulatory frameworks. OK, so what are states doing about it? Colorado recently suffered some high-profile recalls of marijuana batches contaminated with harmful pesticides that made it into some of the edibles. Evidently, growers sometimes find themselves overwhelmed by pest issues and resort to nuclear tactics, trying anything to protect their crop. This has created a public health threat, with intensified toxicity in concentrated products of particular concern. Pesticide levels were found to be approximately 10 times higher in concentrated cannabis products, like the oils and waxes sometimes used in edibles or dabbed as concentrates. A study of pesticide use on cannabis crops in Oregon found a similar problem. A survey of samples off store shelves in Washington state found 5 out of 6 contaminated, including with potentially neurotoxic and carcinogenic agents. Many samples harbored multiple contaminants, attaining levels basically off the charts, including 24 distinct pesticide agents, insecticides, fungicides, none of which are approved for use in cannabis. But it's not their fault. The EPA hasn't approved any because it's still a federally illegal crop. In fact, testing labs in California have become hesitant to publicize their service or list agents for which they could test, as they suspect that such information might be used as like an instruction manual by unscrupulous growers to seek out even more toxic agents. OK, so just regulate it. They've tried, but guess what was the biggest barrier they came up against? Surprise, surprise, the cannabis industry, the multi-billion-dollar cannabis industry. Like the tobacco industry before it, the cannabis industry is attempting to weaken pesticide regulations. Reportedly, the Colorado Department of Agriculture initially hoped to limit permissible pesticides to the most non-toxic, but this proposal was quashed by industry pushback, just like the tobacco industry was able to do. Big Tobacco has provided a detailed roadmap for King Cannabis: deny addiction potential, downplay any adverse health effects, create as large a market as quickly as possible, and protect that market through lobbying and campaign contributions. Bolstered by enormous profits, the tobacco industry was able to get itself exempted from every major piece of consumer protection legislation. So that should be a cautionary tale for us now, given that public health advocates have definitively fewer billions to work with. Big Tobacco may not just be providing the roadmap, but waiting in the wings to own the road. As a result of lawsuits against the tobacco industry, more than 80 million pages of internal company documents became available, and what they reveal is that since at least 1970, despite fervent denials, major multinational tobacco companies like Philip Morris have been scheming, willing and prepared to enter the legalized marijuana market to become Big Blunt. Because the tobacco industry's demonstrated ability and willingness to modify its products to increase addictiveness, obfuscate information, deceive the public, and target vulnerable groups to increase demand, the industry has the power to dramatically change the game. Nearly a half-century ago, at a Senate hearing on nutrition, a Dr. Neisel from Tufts suggested that sugary breakfast cereals should be banned in the best interest of all concerned, particularly children. Perhaps not surprisingly, since he was a professor of dental medicine. A dozen different foods and beverages were ranked for their cariogenic potential, their cavity-causing potential, by implanting electrodes in the mouths of study subjects to measure the amount of acid produced in the plaque between their teeth after eating a variety of different things. And the two breakfast cereals they tested topped the charts. If you drink some sugar water, the pH on your teeth plunges within minutes into the acidic danger zone and stays there for an hour, eating away at our teeth. Caramel is worse. It sticks to your teeth, so it stays longer, down deeper into the acid zone. But check out the breakfast cereals. Goes down and stays down even 2 hours later. We've known about the cavity-causing potential of pre-sweetened breakfast cereals for decades. A dozen such cereals were put to the test to measure the level of tooth-dissolving acid produced by the strain of bacteria that causes cavities. As one might expect, the cavity-generating potential was found to be related directly to the sugar content of each cereal, though Frosted Mini-Wheats was an exception. Despite having 40% less sugar than cereals like Froot Loops or Frosted Flakes, Frosted Mini-Wheats caused the greatest calcium demineralization, ranking second only to the now-defunct powdered donuts in cavity-causing potential. A study of 28 different cereals concluded that unquestionably the sugar concentrations in these 28 cereals was sufficiently high to qualify them as dentally dangerous. Wanting to be good corporate citizens, General Mills took their Super Sugar Crisp, which was 44% sugar, and reduced the sugar font size. Then, caring about children's health so much, they removed sugar altogether from the name. Kellogg's cares too. Though Sugar Smacks is apparently where space energy comes from, it doesn't sound as wholesome as Honey Smacks. Same cereal, healthier name. They did remove sugar from Corn Pops and Frosted Flakes. From the front of the boxes. And Cookie Crisp? I think the fact that it's made by a dog food company says it all. But General Mills protests a study they did in which teens were randomized to receive free cereal delivered to their homes or not didn't seem to get any more cavities, proving breakfast cereal is harmless for your teeth. Anyone care to take a guess at the study's fatal flaw? The kids in the control group were free to just have their parents buy their sugary cereals from the store, and so both the experimental and control groups may have been eating the same amount of cereal, with the only difference being that the experimental group received its cereal free, and the control group had to pay for it. What did the General Mills researchers have to say for themselves? Dietary control so rigid as to exclude the ingestion of cereals by children would be difficult, if not impossible. But then it's not a control group. That's like this Kellogg's-funded paper saying, yeah, if we didn't feed kids sugar, then we could virtually eliminate cavities, but this ideal is impractical. So, let's take the middle ground and come up with, Fruit Loops with marshmallows. But hey, at least they're fruit-shaped, or at least fruity-shaped. Observational studies have also failed to link breakfast cereal consumption with cavity prevalence, though, or incidence. This is presumed to be because eating it with milk helps clear food particles from the mouth, though frosted mini-wheats did lead to the same sugar retention in the saliva 10 minutes after intake with or without milk. The other cereals were cleared out faster. Sugared cereals are often eaten as snacks by kids, though, without milk. And 10 minutes after the ingestion of dry, sugary cereals, you're left with nearly 50 times the sugar residue in your mouth, compared to swishing the sugar down in liquid form. It is inconceivable, conclude the researchers, to contest the fact that frequent between-meal ingestion of foods like high-sugar cereal is dentally hazardous. Whether or not mealtime eating of sugared cereals induce cavities is not the point. Because kids snack on them between meals, they have a marked potential for dental danger. Three-quarters of American adults drink coffee, about half of which on a daily basis. That comes out to 1 million tons of coffee every year. Might there be grounds for concern? Population studies have found that coffee drinkers tend to have lower risk of Parkinson's, less prostate cancer, especially the women, less liver cancer, less diabetes, liver cirrhosis, depression among women, and a reduction in mortality overall, such that coffee drinkers tend to live longer than non-coffee drinkers, with mortality bottoming out at about 4 cups a day. But these are all just associations. You don't know if it's cause and effect until you put it to the test. For example, coffee really does seem to protect the liver. Take people with chronic hepatitis and have them drink coffee or not for a month, then switch them back, and the coffee really did seem to help. Similarly, randomize Parkinson's patients to get 2 cups of coffee worth of caffeine and get a significant improvement in movement symptoms within 3 weeks. Runners randomized to drink coffee shaved about 6 seconds off their mile. Weightlifters randomized to coffee can squat more weight, about 600 pounds more worth of reps, and not just athletic performance. A cup of coffee's worth of caffeine can significantly improve IELT, which stands for intravaginal ejaculation latency time, from 2 minutes all the way up to 5. Unfortunately, those effectively randomized at birth to genetically just have higher predilection to drink coffee do not appear to be protected from diabetes, or depression, or Alzheimer's, or obesity, or metabolic syndrome, so it seems the protective associations may just be due to confounding factors, like maybe those who drink coffee just happen to exercise more or something. And the same with prostate cancer. No apparent cause and effect relationship, and even the mortality benefit seemed to disappear. Even if a study did show coffee drinking could extend lifespan by reducing inflammation or improving lung function or insulin sensitivity, that would mean on average. There is inter-individual variability after consumption of major plant food compounds, meaning people may respond differently. For example, how crazy is this? In some rare individuals, heavy use of caffeine apparently provokes sleepiness. That's an extreme example. Most of the time, it's just that some individuals may benefit more than others from the health effects of different foods. For example, because of differences in gut bacteria, only a minority of Westerners may derive extra benefit from soy, as I've described before. The most common difference in caffeine effects is that, while most people metabolize caffeine rapidly, certain gene variants in liver detox enzymes make some people slow metabolizers. Might that make a difference? Well, habitual coffee consumption of at least 3 cups a day has been associated with uncontrolled blood pressure among older individuals diagnosed with hypertension, suggesting that moderating coffee intake may be a good idea for some people. But even if it was cause and effect, that would be on average. What would happen if you split people up by how fast they metabolize caffeine? Compared to coffee abstainers, those who have impaired caffeine metabolism genes have an elevated risk of becoming hypertensive at 1 to 3 cups a day, and especially at 4 or more. OK, but check this out. For the rapid metabolizers, not only was there no excess risk at 1 to 3 cups, heavy coffee drinkers were protected, meaning apparently the more coffee they drank, the lower their risk. How do we explain that? Well, coffee is a complex blend of a vast number of different compounds. There are protective polyphenol antioxidants that are beneficial. Coffee beans are, after all, beans, well, actually seeds, but seeds are really healthy too. On the other hand, there's the caffeine, which can spike adrenaline levels in the blood, but only if you're a slow metabolizer. Rapid metabolizers can clear caffeine so fast that there's no increase in adrenaline, even at 4 or more cups a day. And so then you just have the beneficial polyphenols that actually lower your blood pressure, hence the benefit overall. Thus, there seems to be a Jekyll and Hyde aspect to coffee whose overall action on the cardiovascular system appears to be regulated by that gene for the enzyme that metabolizes caffeine. The important question, though, is, does it give women larger breasts? What? Young women who drink a lot of coffee and are rapid caffeine metabolizers have about half a baseball-sized larger breast volume, which may be a bad thing, as breast volume is associated with breast cancer risk. But no, the important question is, what about heart attack risk? In slow metabolizers, daily coffee consumption appeared to double the odds of a heart attack, or even quadruple the odds at 4 cups a day, whereas in the rapid caffeine metabolizers, daily coffee consumption was protective, cutting the odds of a heart attack by more than half, or at least until you get up to 4 more cups a day. The protective effects observed among rapid metabolizers suggest that the efficient elimination of caffeine might have unmasked the protective effects of other phytochemicals in coffee. We think it may be the adrenaline again, since if you're a slow metabolizer of adrenaline, high coffee consumption may put you at risk as well. So, is coffee friend or foe? These studies suggest the possibility that slow caffeine metabolizers who consume caffeinated coffee may have an increased risk of cardiovascular disease, whereas fast caffeine metabolizers may be protected from this risk by the antioxidants and other beneficial compounds present. There has been a long-standing problem among zookeepers of the gorilla, a Latin name gorilla, gorilla, gorilla. The problem is that they were throwing up all the time. We've never seen wild gorillas barfing, but it had unfortunately been accepted as routine by many zoos. What were they feeding them? Well, they're big, strong animals, so they made sure to feed them lots of protein, cottage cheese, meat, eggs, milk, until a zoo in Germany got this radical idea to try giving them their natural diet, and the change following the alterations to the diet was astonishing. I mean, before, the poor silverback was regurgitating and vomiting during most of the day, but by the third day eating what they were supposed to eat, he and the rest were all miraculously cured. Even just removing milk from captive gorilla diets led to significant improvements. Cow's milk was historically considered an essential item in the captive gorilla diet, but they showed that removal of milk from the captive gorilla diet may reduce such undesirable behaviors and may be a step towards better approximating their natural diet. I mean, giving an animal milk after weaning? Giving an adult animal milk? Milk is for babies. And then giving milk from a bovine to a primate? What were these crazy zookeepers thinking? Doesn't make any sense. Reminds me of this landmark study. 81 children presenting with reflux, gastroesophageal reflux disease. So they were given drugs, and 2/3 got better, but 27 kids still did not. So they tried eliminating cow's milk from their diets, and within 1 month, all 27 were cured. Symptoms of acid regurgitation, heartburn, or both, occur at least once a week in 10 to 20% of adults in the Western world, and about up to 25% of all infants. Now, it's normal for babies to spit up occasionally. That's not what we're talking about. It can actually get quite serious. Up to a quarter of infants present with regurgitation severe enough for parents to seek medical help. And it may just be that they're sensitive to cow's milk. The symptoms of cow's milk protein allergy overlap and may coexist or complicate GERD reflux. Even if there's no formal dairy allergy per se, there appears to be some kind of cow's milk hypersensitivity among many infants and children with severe reflux. There's all sorts of invasive tests you can do, like stick pH probes down the poor baby's throat, but probably the most practical test in routine pediatric practice is just a trial of a cow's milk protein elimination diet for 2 to 4 weeks in infants with reflux. The gold standard is what's called an elimination and re-challenge protocol, where you see full resolution of symptoms via strict elimination, followed by recurrence of the symptoms on reintroduction of cow's milk protein. And when you do that, take 200 or so infants diagnosed with reflux, and then not only put them on a cow's milk-free diet, but then do the challenge test, 85 of the 204 infants with reflux were actually suffering from a cow's milk allergy, or at least hypersensitivity or something. What we think is happening is that our immune system attacks the bovine proteins as understandably foreign, triggering an inflammatory response, which irritates the nerves lining your digestive tract, and that results in abnormalities in the rhythmic contractions of the stomach, triggering the regurgitation. We're not just talking about formula-fed infants. Cow's milk protein allergy can occur in exclusively breastfed infants, as intact cow's milk proteins can be secreted in breast milk. If the mom drinks milk or eats eggs, it can get into her baby. Cow's milk protein and other foreign proteins can pass into human breast milk. So breastfed infants with regurgitation and vomiting may therefore benefit from a trial of withdrawal of cow's milk and eggs from the maternal diet. And indeed, that is now the consensus recommendation of both the North American and European Society for Pediatric Gastroenterology, Hepatology, and Nutrition. Anytime you see reflux, let's first try a therapeutic trial of either cow's milk protein-free formula, or, for infants who are breastfed, a maternal strict cow's milk protein elimination diet. And so then we can potentially treat the cause without using unnecessary medications, and certainly before you start considering performing any anti-reflux surgery on the poor kid. There are all sorts of different scoring systems to rate diet quality. My favorite, for its simplicity, is the Dietary Phytochemical Index, a fancy name for a simple concept. It's just the percentage of your calories from whole plant foods, so 0 to 100. The average American diet has a score of 12 out of 100. So like on a scale of 1 to 10, our diet is a 1. You can split people up based on how they score and show how the higher you score, the better your metabolic markers when it comes to diabetes risk. There appears to be like this stepwise drop in insulin resistance and insulin-producing beta cell dysfunction as you eat more and more plant-based. And that highest group was only scoring about 30. Less than a third of their diet was whole plant foods, but better than the lowest, which was down around the standard American diet. No wonder. Diets centered around plants, emphasizing legumes, beans, split peas, chickpeas, and lentils, whole grains, vegetables, fruits, nuts, and seeds, and discouraging most or all animal products, are especially potent in preventing type 2 diabetes, and as a little bonus, has been associated with much lower rates of obesity, hypertension, hyperlipidemia, cardiovascular mortality, and cancer. And not just preventing type 2 diabetes, but treating it as well. A systematic review and meta-analysis found that the consumption of vegetarian diets is associated with improved blood sugar control. But how much improved? Here's one of the latest trials. The effect of a strictly plant-based diet centered around brown rice, it was done in Asia, versus the conventional diabetic diet on blood sugar control of patients with type 2 diabetes, a 12-week randomized clinical trial. For the diabetic control diet, they set up food exchanges and calculated specific calorie and portion controls, whereas on the plant-based diet, people could eat as much as they want. That's one of the benefits. The emphasis is on food quality rather than quantity, and they still actually lost more weight. But even after controlling for the greater abdominal fat loss in the plant-based group, they still won out. Of course, it only works if you actually do it, but those that pretty much stuck to the healthier diet dropped their A1C levels 0.9%, which is what you get taking the leading diabetes drug, but of course only with good side effects. Yeah, but would it work in an underserved population? The impact of a plant-based diet support program on mitigating type 2 diabetes in San Bernardino, the poorest city of its size in California. A randomized controlled trial, but not of a plant-based diet itself, as the title suggests, but of just an education program telling people about the benefits of a plant-based diet for diabetes, and then it was up to them. And still got a significant improvement in blood sugar control. Here are the numbers. Got a little better in the control group, but way better in the plant-based instruction and support group. And more plant-based diets are not just effective in the prevention and management of diabetes, but also its complications. Check this out. One of the most devastating complications of diabetes is kidney failure. This shows the decline in kidney function in 8 diabetics in the 1 or 2 years before switching their diets. They all showed this steady, inexorable decline on a fast track to complete kidney failure and dialysis. But then they switched to a special supplemented vegan diet, and their kidney decline was stopped in its tracks. Imagine if they had switched a year or two earlier. Most diabetics don't actually end up on dialysis, though, because they die first. Cardiovascular disease is the major cause of premature mortality among diabetics. That's why plant-based diets are perfect. There's a general scientific consensus that the elements of a whole food plant-based diet, legumes, whole grains, fruits, vegetables, and nuts with limited or no intake of processed foods and animal products, are highly beneficial for preventing and treating type 2 diabetes. Equally important, plant-based diets address the bigger picture by simultaneously treating cardiovascular disease, our #1 killer, along with obesity, high blood pressure, lowering inflammation, and we can throw cancer into the mix too, our #2 killer. The bottom line is that the case for using a plant-based diet to reduce the burden of diabetes and improve overall health has never been stronger. Orthorexia nervosa is described as a fixation on the virtue of food, or unhealthy obsession with healthy eating. Orthorexia has been styled as a type of self-righteous eating, or as clean eating by sufferers of the disorder. Wait, let's take a step back here. First of all, though this phenomenon has been described in the scientific literature. It is not formally recognized as an official psychiatric diagnosis. Furthermore, orthorexia doesn't even have an accepted definition, nor validated diagnostic criteria, and if you can't validly diagnose it or even define it, what good is it? OK, well, first off, where did this concept even come from? Not from some scholarly source, but from a popular press article called Confessions of a Health Food Junkie in a magazine called Yoga Journal. Let's explore its scientific legitimacy. Evidently, it looks like orthorexics obsessively avoid processed foods, unhealthy fats, and foods containing too much salt or too much sugar. But wait, by definition, we should avoid unhealthy fats. They're unhealthy. And anything that has too much salt or sugar has too much salt and sugar. Is someone who's a non-smoker obsessively avoiding cigarettes orthospirexic, obsessed with right breathing? In many cases, parents try to strictly limit their children's sugar intake. No! Off to the loony bin they go. Orthorexics make the nutritional value of a meal more important than the pleasure of eating it. But if you didn't just a little, wouldn't you just eat donuts all day? I mean, if pleasure trumps health, maybe we should all just start shooting heroin. One of the proposed criteria is an unusual concern about one's health. What does that mean? Do you have a mental illness if you decide to hold the bacon on your double cheeseburger? That could be seen as an unusual level of concern in a standard American diet. People with orthorexia pay excessive attention to the quality of consumed food, so much so they'd rather not eat unhealthy food. I bet they put their seatbelts on, too. We better reprogram their unhealthy, healthy thoughts with cognitive behavioral therapy, combined, of course, with drugs. SSRIs such as Zoloft, Prozac, and Paxil. Hey, that's what the experts recommend. With regard to psychotropic medication, yeah, SSRIs may help, but you may have to dip into the atypical antipsychotics as well. Now, often there'll be a concession like, of course, from a clinical and public health perspective, it would not be reasonable to suggest that individuals who follow a strict healthy diet are endangering their health. It only reaches clinical significance when health-directed eating starts causing problems in relationships or impairs an individual's social life. But if someone asks their spouse not to smoke around them and the kids, that health-directed behavior could cause interpersonal distress in the relationship. Should you just keep quiet? Or should you yourself keep smoking just to not cause waves with your smoking spouse? And social life-wise, do you have a mental illness if you tell your date you'd rather not go to the steakhouse or the smoking lounge? The problem is when the behavior begins to hinder a person's ability to take part in everyday society. Like what if you start bringing food to dinner parties? Maybe I've just gone to too many potlucks, but bringing a healthy dish to share doesn't sound like a druggable psychiatric offense to me. And then there's Instagram. Think of the implications social media can have on psychological well-being of hundreds of thousands of individuals. Did you know that healthy food posts tend to receive more support from users than less healthy images, indicating a positive attitude towards healthy foods and healthy eating? Soon, everyone might be taking pictures of broccoli. Quick, get out the straitjackets. In his decades of medical practice, Dr. Dean Ornish says he's never seen a case of orthorexia. Most people, he says, have the opposite problem. They don't care enough about what they eat. Orthorexia nervosa is an unrecognized eating disorder in which the person becomes obsessed with eating healthy foods, whereas recognized eating disorders like anorexia deal with the quantity of food. Orthorexics care about the quality of their food. Many researchers have raised questions about the validity of orthorexia as an entity, but I always try to give the benefit of the doubt. A medical case report was published on orthorexia in a critical care journal about eating disorder emergencies. OK, I'm listening. So they're like talking about cases of bona fide eating disorders like this woman with anorexia, collapsing after self-induced vomiting, and laxatives after years of throat and rectal bleeding. I mean, that is indeed a tragic eating disorder emergency. OK, so what's their orthorexic case like? A 53-year-old man who had triple bypass 2 years ago comes in for a checkup. His physician recommends seeing a dietitian since his BMI is down to like 18.5, which is right on the cutoff for being underweight. He's evidently been eating so healthy he's lost a significant amount of weight. He states that since his diagnosis of coronary heart disease and high cholesterol, he only eats natural and organic foods. Therefore, he probably has a psychiatric illness. He clearly is preoccupied with food and judges others based on their food choices, when, in fact, he may very well have been saving his own life. I mean, to me, the craziest thing this guy did was get a triple bypass. I mean, imagine lying on a psychiatrist's couch and being like, I could switch to bean burritos, but I'd rather pay someone to slice my chest open with a knife, maybe saw my breastbone in half, put me at risk for stroking out, instead of dealing with the underlying cause. What do you think, Doc? Then we could see some orthorexics becoming evangelical as they share their feelings of disgust or disappointment towards their family, friends, or even children for their quote-unquote normal food choices. I mean, it's bad enough they care about their own health, but caring about their family and friends, their children, off to the funny farm you go. I mean, it's not like what we eat is the #1 cause of death in the United States, or anything, killing hundreds of thousands more Americans every year than cigarettes. Oh wait, it is, and also the #1 cause of disability. But you may have a mental illness if you're disappointed that your kids are eating multicolored marshmallows for breakfast. If you recognize these warning signs, what should you do? You should confront the person. I know it's not easy, but if you see someone obsessively trying to avoid unhealthy foods, and worse, trying to get others to do the same, then confront them. The possibility of helping them save their own life far outweighs uncomfortable emotions. The irony, of course, is that they're trying to save your life. Right? Imagine if you were able to talk Mr. Triple Bypass out of his healthy eating obsession. You'd probably kill him. To his credit, even Stephen Bratman, the guy who coined the term orthorexia, has backed off, saying that he never intended to propose a new eating disorder. As an alternative medicine practitioner, he just wanted his patients to relax their dietary corset and live a little. I mean, where did people get this idea that he was trying to coin the name for a novel eating disorder? I mean, if you go back to his original article, he just said he was trying to coin the name for a novel eating disorder. An eating disorder he saved himself from, saved from the doom of his eternal health food addiction with the help of tacos, pizza, and a milkshake. One of the directors of the Yale Center for Eating Disorders is skeptical. We've never had anybody come into our clinic with orthorexia, and I've been working in this field for at least 20 years. Without research to back his theory, Bratman is simply another guy trying to make a buck off the health-conscious public. They invent some new term, a new diet, a solution to a problem that doesn't even exist. The burden should fall to the authors to prove what they're saying is correct before they start unleashing advice on the public. Orthorexia is defined as an unhealthy obsession with eating healthy food. Want to know if you're orthorexic? The Ortho15 is the most widely accepted assessment tool to screen for orthorexic tendencies. A score of 40 or lower was considered the best threshold for an orthorexia diagnosis. There are 15 questions, each scored from 1 to 4, so you can end up with a score of 15 to 60, with a score under 40 denoting orthorexia. So getting 1s and 2s, or even an occasional 3 in your answers would mean you may have it, so lower scores are worse. OK, let's check it out. The first question, when eating, do you pay attention to the calories of the food? always, often, sometimes, or never. According to the test, the healthiest answer is often, with the orthorexic answers being always or never. I can see how always obsessively worrying about calories could hint at a problem, but if you're eating healthy enough, right, a diet centered around whole plant foods, you don't need to worry about calorie counts or portion control, and the healthiest foods, fruits and vegetables, don't even have a nutrition label. But apparently, if you're never Googling the calories of every apple you eat, you may have a problem. When you go to the grocery store, do you feel confused? Supposedly, the healthiest answer is always. You should always be confused, and if you're not at least often confused, we may end up having to drug you. Question number 3. In the last 3 months, did the thought of food worry you? The supposed healthiest answer? Never. The thought of what you're putting into your body didn't worry you once. According to the test, it would be healthier if your eating choices were conditioned worries about your health, and of course, taste should always be more important than the quality of your food. I mean, if you think the quality of food is even sometimes more important, you may have a mental illness. And if you're often willing to spend more money to have healthier food, crazy! Are you so delusional that you think consuming healthy food might improve your appearance? My favorite, though, has to be question 14. Do you think that supermarkets also sell unhealthy food? You've got to be kidding, right? And then they penalize people who live alone. If you scored under 40, you are not alone. Using this test, about 50% of registered dietitians in the United States are supposedly suffering from a mental illness. The prevalence of orthorexia nervosa presents as being impossibly high. I mean, anorexia and bulimia are estimated to be no higher than about 2%, and so it's kind of counterintuitive to believe that there's some eating disorder out there that has rates as high as nearly 90%. No wonder the DSM, the Psychiatry Profession's official diagnostic manual, does not include orthorexia as a psychiatric diagnosis. And look, they love turning things into mental illnesses. The latest edition can turn kindergarten temper tantrums into a disorder, too much coffee, or even bad PMS into a mental illness. But they're still not going to go there with orthorexia. For example, researchers have a tendency to pick and choose which questions of the Ortho-15 they use and come up with their own cutoff scores for diagnosis, resulting in an alarmingly erratic use of the Ortho-15 tool that was designed to measure orthorexia. The bottom line is that the Ortho-15 test is likely unable to distinguish between healthy eating and pathologically healthy eating, whatever that is. Now, more recently, new criteria have been introduced. Given the impossibly high prevalence rates, new emphasis is placed on health problems because of diet, such as malnutrition or medical complications that would, by definition, make it an unhealthy diet, like this tragic case in which someone had tried to live off a few spoonfuls of rice and vegetables and ended up bedridden. Look, if that's what you want to call orthorexia, fine. But one wonders if it might have been clouded by some actual psychiatric diagnosis like OCD, obsessive-compulsive disorder. And if you add in those adverse health criteria, then the prevalence drops to less than 0.5%, which seems a little more reasonable. Interestingly, those eating vegan diets had the least pathological scores in the sample, though this may reflect them just being less serious about healthy eating, reaching for the vegan donut rather than the lentil soup. Corporations are legally required to maximize shareholder profits, and therefore have to oppose public health policies that could threaten profits. It's just how the system is set up. Unequivocal, long-standing evidence shows that to achieve this, diverse industries with products that can damage health have worked systematically to subvert the scientific process. Take the sugar industry, for example. Internal documents show that they were concerned that health food faddists were becoming an active menace to the industry. Sugar was under attack, and many of the poor, unfortunate public swallow the misinformation broadcast by the propagandists. What were books like Yudkin's Pure, White, and Deadly saying? All the propaganda is to the effect that sugar is a non-essential food. No! How dare they say sugar is a non-essential food? I mean, next they'll be saying it's not really food at all. And that was the sugar industry's line. Sugar is a cheap, safe food. And this coming from the founder and chair of Harvard's nutrition department, Frederick Stare, long known as Harvard's sugar-pushing nutritionist. Not only did the sugar industry try to influence the direction of dental research, but heart disease research as well, paying Stare and colleagues to write this review to help downplay any risk from sugar. Now, to be fair, this was 5 years before we even realized triglycerides were also an independent risk factor beyond just cholesterol. The main reason attention stayed focused on saturated fat is not because of the might of the sugar industry. There was just not as much data to support it. In fact, the even more powerful meat and dairy industries loved the anti-sugar message. Who do you think sponsored Yudkin? Right? In fact, on the first page of Pure, White, and Deadly, he thanks all the food and drug companies that have provided him with constant, generous support. Who paid for Yudkin's speaking tour? The egg industry, of course, to try to take some heat off of cholesterol. Hegstead, one of the co-authors of the funded review, wasn't exactly an industry cheerleader. He recommended people cut down on all the risky stuff— less meat, less saturated fat, less cholesterol, and less sugar, less salt. It wasn't the sugar industry that got him fired for speaking truth to power. It was the beef industry. The sugar industry was able to conceal its funding because the New England Journal of Medicine didn't require disclosure of conflicts of interest until 17 years later. These muckraking researchers suggest policymakers should consider giving less weight to food industry-funded studies. But why is the food industry funding studies at all? Right? I mean, when it comes to the corporate manipulation of research, ultimately, conflicts of interest don't just need to be disclosed and managed, but ideally eliminated. Right? Things may not change until public health researchers start refusing to take money from the junk food industry, period. It worked for tobacco. Many prestigious medical and public health institutions have instituted bans on tobacco industry funding. But wait, can't scientists remain objective and impartial even in the face of all that cash? Apparently not, as industry-funded research has been shown to be up to 88 times more likely to produce funder-favorable outcomes. What, do we think corporations are in the business of just handing out money for free? The classic example is the American Academy of Pediatric Dentistry, who accepted a $1 million grant from Coca-Cola. Before the grant, their official position was that the frequent consumption of sugary beverages can be a significant factor in the initiation and progression of dental cavities, which after the grant changed to scientific evidence is certainly not clear on the exact role the soft drinks play. As CSPI's Integrity in Science project put it, what a difference $1 million makes. In 1869, a patent was taken out for a new substance to replace elephant ivory in the production of billiard balls, and the plastics industry was born. Ironically, what started out as a conservation-minded measure has turned into an environmental problem. Hundreds of thousands of tons of trillions of tiny plastic particles are now floating on the surface of the sea. This is how it works, either from plastic objects like water bottles that get worn down into tinier and tinier pieces, or plastic microbeads flowing down into the sewers from our sinks. Plastic microbeads are often used as a scrubbing agent in personal care and cosmetic products, such as facial cleansers, shower gels, and toothpaste. And up to 94,000 microbeads could go down the drain in a single wash. Then when you trawl the oceans, you can find the same beads you find in the facial scrubs. Billions are emitted into aquatic habitats every day in the United States. Laid end-to-end, the United States emits enough microbeads to wrap around the planet more than 7 times. The reason this may be a problem is that the plastic then accumulates toxic compounds from the water and then shuttles them, along with any chemicals originally in the plastic, into marine organisms, concentrating up the food chain and eventually ending up on our plates. The potential hazardous effects on humans then evidently includes alterations in chromosomes, which lead to infertility, obesity, and cancer. Wait, let's take a step back and review the evidence. Plastic gets into the oceans, but does it even get into the fish? Yes, microplastics have been shown to be ingested by fish and other seafood. But are we then actually eating plastic-ingesting fish? Yes, we are eating plastic-ingesting fish. But don't we just poop the plastic out? Small enough microparticles may actually be able to get absorbed through the intestinal wall and into our bloodstream. This uptake of ingested microparticles into small intestinal tissues and onto secondary organs has moved from being an anecdotal phenomenon to a recognized and quantifiable process. But that's in rodents. Just because it's been demonstrated across a variety of lab animals, you don't know if it happens in people until you put it to the test. The closest we have is working with human placentas after childbirth, and what they found is that plastic microparticles could indeed cross the placental barrier from the maternal bloodstream. So if it could get into a pregnant woman's circulation, it might get into her baby's circulation as well. The reason this is concerning is that plastic debris can be a source of toxic chemicals, both chemical additives in the plastic itself, and then pollutants the plastic sucks up from the water that can then be later released into the body. BPA is one of the chemical additives that can originate from the plastic itself. Given that BPA concentrations have been measured in plastic debris, microplastics may be a major source of BPA in seafood, but no one's really looked into it until now. BPA levels in the edible parts of seafood. Yes, fish and seafood present one of the highest BPA contamination levels, but is that just because they were looking at canned fish products like tuna and sardines? Manufacturers may use BPA in the lining of food cans directly. Yes, BPA may also leach from the plastic in the oceans, causing a direct contamination of the fish. In fact, some argue that this BPA environmental contamination of fish could be worse than the BPA from the cans themselves, but you don't know until you put it to the test. Here are the BPA levels found in canned seafood. You can see the highest levels were found in tuna, cockles, sardines, and blue crab. But these were all canned, so you don't know how much is from the can versus the seafood itself. Until you look at non-canned seafood, and sometimes found even higher levels in some fresh mollusks, clams, flounder, and cod. That's not good, since plastics chemicals such as BPA are known endocrine disruptors, meaning known hormone disruptors. And besides that, fat-soluble pollutants from the seawater can glom onto the microplastic surfaces and potentially present additional risk, which we'll cover next. Plastic debris in the sea is more than just an unsightly problem. The concern is not so much discarded bobbing bottles as tiny microplastic particles, raising questions about cancer. Wait, what does plastic have to do with cancer? Well, back in the 1950s, researchers had observed that when they wrapped the kidneys of rats with cellophane to cause high blood pressure, they ended up inadvertently causing cancer. Cancers had started growing around the cellophane. So they tried slipping all sorts of different plastics under the skin of rodents, and they all could produce malignant tumors. And then if you feed rats some plastic microbeads, up to 6% of the particles end up in their bloodstream within 15 minutes. So could all this microplastics pollution be one of the reasons we're seeing an increased number of tumors found in wildlife? Perhaps the global increase in wildlife cancer should be like a wake-up call. Now, we don't know if it's the plastic itself, or some of the chemical additives like BPA that are to blame. Maybe just the plastic particles stuck in your body causes some sort of mechanical irritation beyond the chemical impact of the plastics as carriers of possible carcinogens. Some plastics may be cancer-causing in and of themselves, but all plastics readily accumulate harmful chemicals, such as persistent pesticides like DDT, and PCBs, flame-retardant chemicals, increasing their concentrations by orders of magnitude. This process is then reversible, with microplastics releasing contaminants upon ingestion. So plastic debris may act as a vector, transferring persistent, bioaccumulative, and toxic substances from the water to the food. And plastics are known to concentrate pollution from water by factors of up to 1,000,000 times, for example, for PCBs. In fact, that's one of the ways environmental scientists sample for contaminant levels. They use plastic to sponge up the pollutants. The concern, then, is that the plastic takes up all these toxins, and then deposits them into the aquatic food chain, where they can climb up the food chain and ultimately into humans. But this was all just theoretical, until now. Chemical pollutants glommed onto ingested microbeads from personal care products do indeed accumulate in fish. The longer you feed polluted microbeads to fish, the higher the levels of fish flesh contamination. So you can see how pollutant levels can then concentrate up the food chain with maximum exposure in the apex predators like killer whales or people. Right? The herring can eat a bunch of brine shrimp. Cod eats a bunch of herring, then halibut or tuna eat a bunch of cod, and then we can scoop it all up in the end. So we know ingested plastic can transfer hazardous chemicals to fish, which can then accumulate and cause liver toxicity and pathology in the fish. But what about in people? Well, we know that in the U.S., of all food categories, fish has the highest levels of PCBs, dioxins, other pollutants, but we don't really eat a lot of fish in this country, so is it really a problem? Well, it's hard to come up with a tolerable daily intake of these kinds of chemicals, but the World Health Organization recommends staying under 1 to 4 units a day, measured in picograms of toxic equivalents. The European Union came up with a smaller number, like no more than 2 a day on average. In the U.S., we're already past that. So there is some concern for toxicity from PCBs, given the current levels of PCBs and plastic debris polluting the ocean. So there's no room for additional PCB body burden. So what can we do about it? Well, we can practice the 3 Rs, reduce, reuse, and recycle plastic items, for example, shopping with reusable tote bags. On a policy level, we could ban the use of plastic microbeads in cosmetics and personal care products, though ideally all countries would do it together, since plastic debris dropped anywhere on Earth may end up being transported to the ocean, where it can travel around the world. So whatever strategies are adopted, international cooperation will be critical in limiting the risk to the oceans and the risk to humans from eating seafood. Microplastic pollution of our waterways may not just represent a threat to marine ecosystems, but also to human health. It's evident we're exposed to microplastic pollutants in seafood, which may create a food safety risk. But is there some seafood less contaminated than others? The first published study looked at mollusks. Eating an average serving of mollusks, you consume about 90 plastic particles, whereas an average serving of oysters may contain only around 50. As a result, the annual dietary exposure for European shellfish consumers can amount to 11,000 swallowed microplastics per year, though we don't yet know what kind of risk this would carry. Of course, due to their persistent nature, microplastic abundance is only going to get worse. It's inevitable that humans eating seafood will ingest at least some microplastics, particularly when the entire creature is consumed, such as mussels, oysters, and small fish. So what, like sardines? We didn't know until now. Contamination of microplastics and mesoplastics, which are like little pieces of plastic larger than a millimeter. They looked at 20 brands of canned sardines from 13 countries over 4 continents, and only found plastic particles in about 1 in 5. They suggested the disparity may have been due to improper gutting in the contaminated samples, but in mammals at least, ingested microplastics can get through the gut wall and circulate throughout the body, and even cross the placental barrier. So do microplastics actually make it into the muscles of the fish, like a fish fillet? Let's find out. If you compare the level of microplastics in eviscerated flesh versus the organs, surprisingly, sometimes the flesh actually contained higher microplastic loads than the excised organs, which highlights that evisceration does not necessarily eliminate the risk of microplastic intake by consumers. Microplastics of all colors, shapes, and sizes were detected in all investigated fish muscle samples, so they do actually get into the flesh. So the average intake of microplastics from eating flathead grouper, shrimp, scat, or barracuda may be in the hundreds per 300-gram serving, or just in the dozens of plastic particles in a 2-ounce child serving. Besides the plastic itself, the particles may release absorbed pollutants like PCBs, and also release plastics chemical additives like BPA, which collectively may cause hormone disruption, cancer risk, and DNA damage. Hence, although there's no standard, tolerable dose for microplastics ingestion, as well as information on exact toxicity of different plastic types in the human body, taking weekly servings of these kind of fish may threaten the health of consumers, especially vulnerable groups, including pregnant and breastfeeding women and children. In the U.S., anthropogenic debris, meaning man-made materials, were found in a quarter of individual fish and in 2/3 of all fish species tested, and also about 1/3 of individual shellfish samples, demonstrating that man-made debris has infiltrated the aquatic food chain up to the level of humans via seafood. Because this debris is associated with a cocktail of pollutants, this validates the concern that the debris may be transferring these chemicals to humans via diets containing fish or shellfish, raising important questions regarding the bioaccumulation and biomagnification of chemicals, and consequences for human health. Now, this study also included non-plastic debris like foams, film, and fibers, but we know now that the ingestion of microplastics appears to be a widespread and pervasive phenomenon across a number of commercially important mollusks, crustaceans, and fish. So the potential for humans as top predators to consume microplastics as contaminants in seafood is very real, and its implications for health needs to be considered. Despite the existence of considerable uncertainties and unknowns, there may already be a compelling case for urgent actions to identify, control, and, wherever possible, eliminate key sources of microplastics before they ever make it into our oceans. I've addressed how cell phones may affect brain function, and how both cell phones and Wi-Fi may affect male fertility, but what about the effects of Wi-Fi on brain functioning? The possible existence of cognitive effects of these kinds of radio frequency energies has been one of the more contentious discussions in the forever contentious issue of whether exposure has any health consequences whatsoever. Wi-Fi has been called an uncontrolled global experiment on the health of humankind. The effects of radio frequency fields gained new urgency as the World Health Organization officially declared cell phone radiation to be a possible human carcinogen based on brain tumor risks. But their decision has no direct relevance to the possible health effects of Wi-Fi, since the exposures are so much different. We may absorb 100 times less radiation in a typical exposure to Wi-Fi compared to cell phones. But you don't know if there are effects until you put it to the test. Can Wi-Fi affect brain function? To date, more than 100 studies have been published on the effects of these kinds of emissions on human brainwave patterns, as measured by EEG. While the results are mixed, a fairly consistent finding is that even a short duration of exposure to the head can produce small but statistically significant changes in the EEG of resting and sleeping subjects. This effect is acknowledged by most health agencies, but the question is, what do you do with that information? For example, a review sponsored by the European governing body concluded that the relevance of such small changes remains unclear, and we don't even know how it's happening at all. Some have suggested it's an artifact of the test, and that EEG wires may be acting like antennas that carry the wave straight to the brain, in effect contributing to the changes it's been set up to measure. Either way, you don't see the kind of neurocognitive effects with Wi-Fi exposure that you do with cell phones. For example, no measurable effects were found on reaction time or sustained attention. Now, this was testing 2.4 GHz Wi-Fi, but if anything, we would expect even lower levels of exposure from the newer 5 GHz Wi-Fi due to the shallower penetration depth. Though more accurately, a person who spends hours a day glued to a smartphone or tablet may very well experience all sorts of neurocognitive effects, but from the use of this technology, not from the radiation. It's interesting, there's a large literature out there about the health implications of these new technologies for young people, but it's about the content. For example, never before in history has such sexually explicit material been indiscriminately available to youth. And we need to ask ourselves as a society what effect this may be having. Girls and boys are being exposed to a colossal amount of digital media on smartphones, which makes access to pornographic material all too easy, cheap, and anonymous. No longer confined to homes and bedrooms, young people can now watch pornography in school, out in public, just a touch of a button away, and researchers only begun cataloging the effects this may have on young people's attitudes and behaviors. Most college students these days report seeing online pornography as a minor before age 18. Of 1,500 high school boys surveyed, the vast majority admit to accessing web porn, and nearly 1 in 3 for more than an hour at a time. What is that teaching our next generation of men? Researchers sat through and content-coded 400 videos from mainstream internet porn sites, and more than a third of the videos displayed acts of physical violence against women, such as gagging or choking. Yeah, but does watching such material lead to sexually aggressive behaviors? 1,500 10 to 15-year-olds were followed for years to see if there was a link between intentional exposure to such material and later sexually aggressive behavior, such as sexual assault. They found that exposure to violent porn over time predicted an almost 6-fold increase in the odds of self-reported sexual aggression. The question, of course, though, is which came first, right? A major difficulty with interpreting this kind of research is that teens predisposed to that kind of behavior are, of course, the ones who may be drawn to that material in the first place, so no cause and effect link can be established. All we can do as parents is closely monitor what our children are doing to the best of our abilities. Sweden's dietary guidelines are pioneering in many ways. For example, encouraging people to decrease their climate impact by choosing more plant-based foods, which tend to produce greatly fewer greenhouse gas emissions. But I was surprised by this page on the official Swedish National Food Agency website, which translates to cyanogenic glycosides and hydrogen cyanide, encouraging people to stay away from ground flaxseed for fear of cyanide toxicity. As in the ground flax seeds I encourage everyone to eat every day. You can see why this was the first question I got when I spoke in Stockholm. Was the Swedish government onto something? Had I just been duped by big flax-funded researchers who claimed you could eat pounds of ground flax seeds a day without worrying, more than 150 tablespoons a day? First, some background. As many as 1 in 5 plants that we eat produce cyanide. In fact, if you look at the major food crops in the world, more than half are cyanogenic, meaning cyanide-producing. Unlike toxic elements like lead, mercury, arsenic, that can't be broken down into anything, cyanide is an organic molecule, 1 carbon atom attached to 1 nitrogen atom. In this state, it can definitely be toxic, but broken down or complex to something else, and it loses its toxicity. And we have an enzyme in our body that does just that, a cyanide detoxifying enzyme. And that's just one of 5 main ways our body can detoxify cyanide. It does require protein to do it, though, and so that's why you can read about chronic cyanide toxicity among malnourished populations in Africa trying to live off of improperly processed cassava root. But as long as we're getting adequate protein in our diet, our body can detoxify the normal amounts of cyanide we eat every day. Now, there's a rare congenital genetic condition called Leber's disease, where you're born without the ability to detoxify cyanide, and indeed, yeah, you could go blind drinking apple cider or something, but otherwise our bodies evolved to be cyanide detoxifying machines. But, obviously there's a limit. For example, a case of cyanide poisoning after bitter almond ingestion. Not regular almonds, which produce about 40 times less cyanide, but bitter almonds, which you can't even buy. They're used in flavor manufacturing. But if you did, eating 50 of them could kill you, or even just a handful for a small child. This suggests that eating 2,000 regular almonds at one sitting could also be bad news. You can't buy bitter almonds, but you can buy apricots. And apricot kernels, which are the seeds inside the stone, actually have pretty toxic levels, and have indeed been implicated in cases of severe cyanide poisoning, all linked to the Laetrile cult of cyanide, promoting poison for profit that I talked about previously. So I'm totally sympathetic to regulators wanting to take a precautionary approach, but are flax seeds like bitter almonds, where just a few ounces could kill you, or more like regular almonds, where regular dietary intake wouldn't even come close? Although the fact that flax seeds can produce cyanide sounds like it would be a significant health concern, it's not, for several reasons, says flax industry-funded scientists. First, the adult human body has the ability to detoxify up to 100 milligrams of cyanide a day. That's where they come up with their pounds of flax seeds a day are safe number. And if you wanted to eat more than those totally unrealistic 150 tablespoons a day, you could just eat them in baked goods, since cooking destroys the cyanide, and eating 7 or 8 tablespoons of raw doesn't even bump urinary thiocyanate levels, which is an indicator of cyanide exposure, so it doesn't even look like your body's even exposed to it. Thus, the toxicity of flaxseed from cyanogenic glycosides is not, evidently, a realistic health threat. OK, let's unpack that. The cooking part is mostly true. Yes, bake muffins with even like a quarter cup of ground flax each for 15 to 18 minutes at about 450 degrees Fahrenheit, and the cyanide-forming compounds are gone. Looks like the same thing happens with baked bread, but bake ground flax seeds on their own, and even an hour at 350 only wipes out 20%, though baking them whole wipes out 80%. And what, baking in bread or muffins wipes out 100%? How does that make any sense? It's the moisture. It's heat plus water that wipes out the cyanide. Boiling for just 5 minutes can wipe it out, like when making hot cereal or something. And so yes, it's true in most cases that cooking eliminates the cyanide compounds, because typically starts out in a batter, as an egg substitute, or baking crackers, or the dough starts out moist. And so yes, in those cases the cyanide is gone upon cooking. But you can't just spread ground flax seeds on a baking sheet, because they dry out so fast that only a minority of the cyanide is lost. But look, why does it matter if your body doesn't even seem to notice 7 or 8 tablespoons of raw? But that's not true. Urinary thiocyanate excretion doubled at that level, though that's just a sign your body is actively detoxifying it. And if we can detoxify a kilo worth of flax a day, what's the problem? Well, look, even if the adult human body has the ability to detoxify up to 100 milligrams of cyanide a day, first of all, look, kids eat flax too. Second of all, a kilo has more than the 100 you said we could detoxify, about 50% more, and I'm not interested in how much we can detoxify up to. For safety, you're interested in the worst-case scenario, not the best-case scenario. Would someone please just give people different doses of flax seeds and just measure how much cyanide ends up in their blood? But that's never been done until now, which we'll cover next. Flaxseed pack a nutritional punch, and as a bonus, the release of cyanide from flaxseed is below a toxic lethal dose. Well, I should hope so. Back-of-the-envelope type calculations has led industry-funded scientists to assert that a person would have to consume 8 cups of ground flax seeds at a time to achieve acute cyanide toxicity. I'd feel better, though, if it was actually put to the test. Researchers tested flax seeds under worst-case scenario conditions with respect to resulting in higher cyanide levels in the blood. So, 1. Locate the flaxseed with the highest level of cyanide-forming compounds you can find. So they went to stores and bought 15 different sources of flaxseed, and though the average level was 140 milligrams per kilo, which is about typical, they did find one with 220, so they used that one. 2. Maximal mechanical destruction to release the most cyanide, so they used some crazy 20,000 RPM lab grinder. 3. Eat it all at once on an empty stomach, and then keep the stomach empty. And they give it raw, since cooking can often wipe it all out. If the recommended daily dose is like 1 or 2 tablespoons of ground flaxseed a day, I recommend 1 in my daily dozen checklist, they decided to go with 4.5 tablespoons. OK, so what happened? The range of cyanide blood levels that one might estimate to possibly be associated with the clinical symptoms of intoxication would be like 20 to 40. So that would be like here or higher, where we want to stay below. So 4.5 tablespoons on an empty stomach of the highest cyanide-containing ultra-ground raw flax seeds they could find, and the highest individual level rise was just under 14, and the average was down around 6. I mean, there has to be some amount of flax that takes you over the limit, though, so they tested 9 tablespoons and 15 tablespoons, too. Remember, we start to worry at around 20 to 40. 3.5 teaspoons of raw, high-cyanide ground flax on an empty stomach, hardly a blip. 7 teaspoons at a time, same thing. 14 teaspoons, which is 4.5 tablespoons, and there's that 6. OK, but what about a little over 9 tablespoons? That's over a half cup at a time, and that does start skirting toxicity. And finally, what about a whole cup? I don't even know how you'd eat a whole cup at once, but that is too much, putting you in that potential toxic range for about 3 hours. So much for the industry's 8 cups at a time are safe. But even in this worst-case scenario situation, 1 cup raw on an empty stomach, the highest dose they could find, that person still didn't actually have any clinical symptoms. This is consistent with the fact that there's not a single published report of cyanide poisoning after consumption of flax seeds anywhere in the literature. Even from Swedish health spas, where they evidently give up to 12 tablespoons as a fiber shock. Usually high doses are like 2 or so tablespoons 3 times a day, and this dose would be safe with respect to possible acute toxicity of cyanide. OK, but what about any possible chronic toxicity? The World Health Organization has something called a PMTDI, the Provisional Maximum Tolerable Daily Intake. It's defined as the amount you can eat safely every day for the rest of your life, without risking any adverse health effects, based on the best available data, though often that's just like rat studies, as it was in this case. If you put varying doses of cyanide in the drinking water of rats for a few months at a certain level, the so-called benchmark dose lower confidence limit, there's a 10% increase incidence of the shrinkage of the tail of the epididymis, which is where sperm is stored in the testicle. That happens at the human equivalent of about 150 tablespoons of flax seeds a day worth of cyanide, but they want to err on the side of caution, so they introduce a 100-fold uncertainty factor to create the PMTDI. So instead of 150 tablespoons of flax seeds a day, the average American should stick to under 1.5 tablespoons a day if you're going to eat them every day. So my tablespoon a day daily dozen recommendation should be safe by any of these standards. Food structure, not just nutrient composition, may be critical for optimal health. It should come as no surprise that cornflakes or Rice Krispies cause a much greater spike in blood sugars than rice or corn on the cob. But it's not just the added sugar. Even with identical ingredients, food structure can make a major difference. For example, if you compare the absorption of fat from peanuts compared to the exact same number of peanuts ground into peanut butter, you flush more than twice the amount of fat down the toilet when you eat the peanuts themselves, since no matter how well you chew, small bits of peanuts trapping some of that oil makes it down to your colon. And the physical form of food not only alters fat absorption, but carbohydrate absorption as well. For example, rolled oats have a significantly lower glycemic index than instant oatmeal, which is just oats, but in thinner flakes. And oat flakes cause lower blood sugar and insulin spikes than powdered oats. Same single ingredient, oats, but in different forms, can have different effects. Why do we care? Well, the overly rapid absorption of carbohydrates after eating a high glycemic index meal can trigger a sequence of hormonal and metabolic changes that may promote excessive eating. They took a dozen obese teen boys and fed them different meals, each with the same number of calories, and just followed them for the next 5 hours to measure their subsequent food intake. And those that got the instant oatmeal went on to eat 53% more than after eating the same number of calories of steel-cut oatmeal. The instant oatmeal group was snacking within an hour after the meal and goes on to accumulate significantly more calories throughout the rest of the day. Same food, but different form, different effects. Instant oatmeal isn't as bad as some breakfast cereals, though, which can get up into the 80s or 90s. Even a cereal with zero sugar, like shredded wheat. The new industrial methods used to create breakfast cereals, such as extrusion cooking and explosive puffing, accelerate starch digestion and absorption, causing an exaggerated blood sugar response added sugar or not. Shredded wheat has the same ingredients as spaghetti, just wheat, but has twice the glycemic index. When you eat spaghetti, you get a gentle rise in blood sugars. If you eat the exact same ingredients made into bread form, though, all the little bubbles in bread allow your body to break it down quicker, so you get a big spike in blood sugars, which causes our body to overreact with an exaggerated insulin spike, and that actually ends up driving our blood sugars below fasting levels, and that can trigger hunger. Experimentally, if you infuse someone with insulin so their blood sugars dip, you can cause their hunger to spike, and in particular, hunger cravings for high-calorie foods. In short, lower glycemic index foods may help one feel fuller longer than equivalent higher glycemic index foods. Researchers randomized individuals into one of three breakfast conditions: oatmeal, made from quick oats, the same number of calories of Frosted Flakes, or just plain water, and then measured how much people ate for lunch 3 hours later. Not only did those who ate the oatmeal feel significantly fuller and less hungry, they indeed then went on to eat significantly less lunch. Overweight participants ate less than half as many calories at lunch after eating the oatmeal for breakfast, hundreds and hundreds of calories less. In fact, if you notice, the breakfast cereal was so unsatiating that the cornflakes group ate as much as the breakfast-skipping water-only group. It's as if the cereal group hadn't eaten breakfast at all. Feed people Honey Nut Cheerios, and hours later they feel significantly less full, less satisfied, and more hungry than those fed the same number of calories of oatmeal. Though both breakfasts were oat-based, the higher glycemic index, reduced intact starch, and reduced intact fiber in the Cheerios seemed to have all conspired to diminish appetite control. The trial was funded by the Pepsi Corporation, makers of the Quaker oatmeal, pitted against the Cheerios from rival General Mills, and an expose on industry-funded study manipulation later revealed that the study originally included another arm, Quaker Oatmeal Squares. I'm sorry that the oat squares did not perform as well as hoped, the researcher told Pepsi, which decided to publish only the results about its oatmeal. Toxoplasma is a brain parasite that may infect 1 million Americans every year, making it a leading cause of severe foodborne illness in the United States. Nearly 1/4 of adults and adolescents in the United States have already been infected. Newly acquired infections in a pregnant woman can be devastating, but in most people with intact immune systems, these parasites just sit there in your brain in a fine-tuned balance between the parasite and your immune system, just laying in wait hoping you'll get AIDS or something, and your immune system will slip, and it can come raging back and spread throughout the brain. But in healthy, non-pregnant individuals, the parasite just sits there long-term as a potentially lifelong resident of your brain, kept at bay by your immune system, without any significant clinical consequence, and so chronic toxoplasma infection has been viewed as a benign condition until now. This absence of overt symptoms has contributed to the view that the cysts in your brain formed by the parasites are dormant entities, but recent developments directly challenge the notion that chronic toxoplasma infections are without consequence. An emerging body of evidence suggests that the presence of an established chronic infection may contribute to the development of a variety of neurological conditions, including schizophrenia, epilepsy, and neurodegenerative conditions. That's not good. Now, these effects may not be a direct consequence of the parasite, but rather driven by a persistent low level of inflammation in the infected brain, but either way, not good. So, let's explore this new data that's gotten neurologists so worried, and review strategies on how not to get infected in the first place, and what one might be able to do to mediate the effects if you are one of the 1 in 4 Americans that's already infected. Suspicions that infections may play a role in mental health date back more than a century. For example, this editorial from 1896 asking whether insanity might be due to a microbe. Well, for millions of years, parasites have altered the behavior of their hosts. Take, for example, the diabolical effects of the rabies virus, which is usually transmitted through saliva, so it makes sense that the virus taps specifically into the limbic system of the brain, turning its victims from Fido into Cujo, to facilitate transmission of the virus. But brain parasites can do more than just switch behaviors on and off. Some parasites can adaptively take over and completely control the behavior of their hosts, like the famous zombie ants. Dying from an infection with an enslaver fungus that steers their insect host to die perched in just the position that favors the dispersal of fungal spores by the wind. Here's the head of a manipulated ant, colonized by tendrils of the fungus. Ants infected by this fungus die in a dramatic way. Once the ant is positioned just right, dying is preceded by the biting behavior, where ants clamp down onto plant surfaces to keep it stable, while the fungus bursts out of the back of the ant's head and grows this long stalk. Here's a picture. How crazy is that? There are also aquatic parasites that cause their insect hosts to drown themselves, or others that can cause bees to bury themselves alive, or cause spiders to build special webs. That's these parasitic wasps that lay their eggs into the spider's abdomen, and then right on the night the larva eats its way out, it marionettes the spider to build it a little home. How creepy is that? OK, but come on. These are insects with simple brains. Surely brain parasites couldn't affect complex behaviors in higher animals, which brings us to Toxoplasma. Toxoplasma is known to manipulate the behavior of their hosts to increase the probability that the host is captured by a predator. For example, Toxoplasma can reproduce in cats. But how's it going to get itself from the brain of an infected mouse into the cat? It can hijack the mouse's brain and hijack their native inborn fear of the odor of cats into an attraction to that odor. The parasite caused the mouse to develop a fatal attraction to cats, which is good for the parasite, not so good for the mouse. What does this all have to do with human mental illness? That's what we'll explore next. Of all foodborne diseases, a brain parasite called Toxoplasma is ranked as the fourth leading cause of hospitalization and the second leading cause of death in the United States. Nearly a quarter of us have already been infected. 1 in 3 of us by the time we hit our 50s. Although we may then be stuck with this thing in our brain for life, our immune system is so good at keeping it at bay for most healthy people, it's never able to rear its ugly head, or at least overtly. Studies have now revealed associations between Toxoplasma infection and the presence of various psychiatric disorders in humans: schizophrenia, bipolar, suicide, self-harm, and memory impairment when we get older. How can a tiny parasite alter our very behavior? I talked about how the rabies virus hangs out in the saliva while specifically targeting the emotion center of the brain to drive animals into a fury, so they'll effectively do the virus's bidding to bite others to transmit the virus. Or the famous zombie ant brain fungus that takes over the animal completely. These are examples of so-called parasitic manipulation, where the parasite manipulates the host to enhance its own transmission by altering host behavior. And Toxoplasma is perhaps one of the most convincing examples of a manipulative parasite of higher animals like us. Since the parasite thrives in cats, chronically infected rodents no longer respond to cat odor with fear, and indeed the physical response is reversed to attraction. Mice become attracted to the smell of cats, serving the parasite up on a silver platter. The parasite manipulates the rodent's brain to turn their innate aversion to cats into a suicidal, fatal feline attraction. Mice become attracted to cat pee, and such fatal feline attraction appears specific towards cats. They don't become attracted to pee in general, remain indifferent to rabbit pee, and continue to be turned off by other predator pee. So on one hand, the parasitic manipulation appears incredibly specific, but the parasite doesn't just want the mouse to seek out the cat, but get eaten as well. And so there are these general effects too: impaired motor function, slower response time, memory and coordination. So when the cat pounces, the parasite tries to make sure the mouse doesn't get away. It's like when California sea otters get toxoplasma, they're more likely to get eaten by a shark. It's not that the parasite wants to get into the shark, it may just be a byproduct of the kind of general cognitive deficits that's so helpful for the parasite in other contexts. It's like when humans get toxoplasma, we start liking the smell of cat pee more too. Isn't that wacky? The parasite knows just what strings to pull. But it's the more general effects we're concerned about. We don't need to worry our newfound appreciation for saber-toothed tiger urine is going to get us eaten. But mucking with our reaction time, that could be a problem. That could be why multiple studies have shown more traffic and worksite accidents among those who are chronically infected. But it may not just be our slowed reaction time. The parasite appears to also affect subtle behavioral alterations, like personality alterations that make us more likely to take risks. Great for the parasite in the cat and mouse game, but not so much if we're driving a car, or wondering whether or not to take the next drink. Maybe one reason people with this brain parasite get into so many car accidents is that it may make people engage in riskier behaviors like excessive alcohol consumption. We typically think of malaria as being humanity's greatest killer parasite. However, when we take into account the hundreds of thousands of deaths that occur due to the increased probability of traffic accidents, working accidents, suicides, and possibly other side effects of the infection, maybe this supposed asymptomatic latent toxoplasma infection that has infested 1 in 4 Americans could easily take malaria down a notch. Before I get into how to prevent and treat the darn thing, what might these other side effects be? How exactly does toxoplasma manipulate behavior? Well, one clue we got decades ago is the rise in dopamine levels in the brain. You can show it right in a petri dish of infected brain tissue. Turns out that these parasites actually have an enzyme to make dopamine from scratch, which they then release into the surrounding brain tissue. Why do we care? Because elevated dopamine is a characteristic of schizophrenia. That's how nearly all modern antipsychotic drugs work, by trying to bring dopamine levels back down, either inhibiting dopamine receptors or decreasing the level of dopamine in our brain. So is it possible that the increased dopamine accumulation and release observed during toxoplasma infection might increase the risk of schizophrenia? Well, that should be easy to figure out. Do schizophrenics have an increased prevalence of infection? The increased prevalence of toxoplasmosis in schizophrenics has been demonstrated by at least 50 studies. The brain parasite toxoplasma infects about 1/3 of the populations of developed countries, about 1 in 4 adults in the U.S. But the lifelong presence of dormant stages of this parasite in the brain and muscles of infected humans is usually considered asymptomatic from a clinical point of view. There's like this dynamic interplay between the parasite, the human brain, and our immune response that results in this détente that promotes the lifelong persistence of the parasite in our brain. We can't get rid of it, but at least we can keep it from killing us, unless we get AIDS or something and our immune defenses drop. Within the past 10 years, however, many independent studies have shown that this parasitic disease could be indirectly responsible for hundreds of thousands of deaths due to its effect on the rate of traffic and workplace accidents, and also suicides. Moreover, this latent toxoplasmosis is probably one of the most important risk factors for schizophrenia. Schizophrenia does have a strong genetic component. But even if you have the exact same genes as a schizophrenic, your identical twin has schizophrenia, the chances of you having it are still probably less than 50%. So what else might increase risk? Studies performed over 5 decades in 20 countries found toxoplasma infection nearly triples the odds of schizophrenia. That's more than any so-called schizophrenia gene that's been described so far. Now, obviously, everyone who gets this parasite in their brain does not come down with schizophrenia. It may depend on where exactly in the brain the parasite ends up taking up residence, but this increased prevalence of toxoplasma in schizophrenics has been demonstrated by at least 50 published studies. Yeah, but what about studies that weren't published? Maybe the ones that found no connection were just shelved or something. even accounting for the so-called publication bias, the evidence of an association with toxoplasma seems overwhelming. Yeah, but it's still just an association. Instead of toxo causing schizophrenia, maybe schizophrenia causes toxo? For example, institutionalized psychiatric patients may be fed undercooked meat, thereby increasing their exposure to toxoplasma infection. That's where the military studies come in. The U.S. military routinely collects and stores blood of its service members. This affords a unique opportunity to check people for infection well before the diagnosis of disease, so you can see which came first. And it was the toxo. The infection can be found prior to the onset of psychotic symptoms. The strongest evidence for a cause-and-effect role of toxoplasma in triggering schizophrenia comes from a recent MRI study showing that differences in brain structure, originally thought to be characteristic of schizophrenia patients, were actually present only in those infected with the parasite. See, there's these gray matter anomalies more often found in schizophrenia patients, but when you split them up into those testing positive and negative for toxo, you only really see it in the infected brains. So does that mean we might be able to treat schizophrenia with antiparasitic drugs? Well, there is this tetracycline-type drug that can kill off toxoplasma in mice, and when given to schizophrenics does seem to improve symptoms. But the drug may also have independent anti-inflammatory and neuroprotective properties, so we don't know if it was a toxo effect. Future research should look to delineate the antiparasitic effect of minocycline by testing the patients for toxo to see if the drugs work better in those who have been infected. There have been 4 randomized controlled trials specifically evaluating antiparasitic drugs in patients with schizophrenia, and no effect was found. But incredibly, not a single one of those studies used a drug that's been shown to actually kill off the parasites once they've been walled off in the brain. See, after acute infection, the parasites form these cysts in the brain, leading to lifelong chronic infection and drug resistance to commonly used antiparasitics. There are currently no ongoing trials of anti-toxoplasma therapy in schizophrenia, despite ample evidence to justify further testing. I hope some researcher listening to this will realize the time is ripe to evaluate antiparasitic drugs in toxo-infected patients with this horrible disease. The brain parasite toxoplasma is responsible for considerable disease and death in the United States, the second leading cause of foodborne-related death in the United States after Salmonella. It can invade through the placenta, so it can be especially devastating during pregnancy, leading to miscarriages or blindness or developmental delay. It can impair cognitive function in adults, too, which explains why those who are infected appear to be at increased risk for getting into things like traffic accidents. Multiple lines of evidence indicate that chronic toxo infections are likely associated with certain psychiatric disorders. It may even increase the risk of developing leukemia. OK, how do you prevent it? Well, the parasite can get into the muscles. So from food animals, people can get it through meat consumption, but in a non-food animal like a cat, you get infected through contact with feces. Thankfully, in cats, the danger of infection exists only when the animal is actively shedding the parasite. They get it from eating infected rodents, and so cats that are kept indoors, that don't hunt, and are not fed raw meat shouldn't pose a threat. Though if feral cats are turning your local playground sandbox into a litter box, that could be a problem. As many as 6% of stray cats, or those with outdoor access, may be actively infected at any one time. They only shed the parasite for a few weeks, though, so if you adopt a cat at a shelter, it should be safe as long as they didn't just come in. Many women have heard about the cat connection, but may be less aware about the risk of foodborne infection. Only about 1 in 3 may be aware that toxoplasma may be found in raw or undercooked meat. Nevertheless, a high percentage of women indicate that they do try to practice good hygiene, such as washing their hands after handling raw meat, gardening where cats may be pooping, or changing cat litter. What's the riskiest type of meat? Well, cattle are not considered important hosts for the parasite. It's more pigs and poultry, as well as sheep and goats. The prevalence of infection among factory-farmed pigs varies from 0 to over 90%, though ironically the likelihood of toxo infection in organic meat may be higher because the animals have outdoor access. Who undercooks pork and poultry, though? Surprisingly, about 1 in 3 Americans may undercook meat across the board in terms of reaching necessary pathogen-killing temperatures, and a single slice of ham can end up with more than 1,000 parasites per slice. Current meat inspection at the slaughterhouse can't detect them. There are tests you can do, but there's no widespread testing. The risk from a single serving of meat, though, is really small. The average probability of infection per serving of lamb, for example, was estimated to be 1 in 67,000. The reason there are 16 times more number of cases attributed to pork is not because pigs are more affected. In the U.S., we just happen to eat a lot more pork chops than lamb chops. Is there anything we can do if we're one of the approximately 1 in 4 Americans already infected? Well, one of the problems with having these parasites in our brain is accelerated cognitive decline as we age. This study evaluated older adults every year for 5 years, and the executive function of those testing positive for toxoplasma seemed to drop quicker over time, as did a measure of their overall mental status. Another thing that's associated with cognitive decline is reduced folate availability, and the two may actually be related, as recent evidence suggests that toxoplasma may harvest folate directly from our nerve cells, sucking up folate from our brain. So beyond dopamine production, which is why we think toxo increases the risk of schizophrenia, the parasite may be sucking folate out of our brain, but enough to affect our cognitive functioning? Perhaps so. Here's a measure of cognitive function across a range of folate concentrations among those uninfected. It doesn't seem to matter whether they have lots of folate or little. They obviously have enough either way. But those who are infected have worse scores at lower levels. Higher is worse in this test. The same thing with vitamin B12. So it's important to get enough B12 and folate. For B12, the official recommendation is that all people aged 50 or over start taking a vitamin B12 supplement or eat vitamin B12 fortified foods every day, and anyone on a plant-based diet should start taking that advice at any age. And folate is found concentrated in beans and greens. So, following my daily dozen recommendations will get you more than enough, as, for example, a half cup of cooked lentils gets you half the way there, as does 3/4 of a cup of cooked spinach. When I was reviewing the science behind common over-the-counter remedies used in dermatology, such as tea tree oil for acne or nail fungus, I was surprised to see on the same page a section on duct tape. Duct tape? The only time I remember seeing duct tape used in a medical study was on the identification of the gases responsible for the odor of human farts, which involved a collection system comprised of gas-tight pantaloons sealed to the skin with duct tape. That's the study where they assessed the wind-breaking ability of a cushion called the Toot Trapper. But what the dermatology journal was talking about is warts. Duct tape brings out our inventive, slightly kooky side. Given this versatility, it wasn't so surprising a few years ago when a group of doctors reported that duct tape could get rid of warts. As I noted in my last wart video, all sorts of strange things are purported to cure warts, because most go away on their own. 1,000 kids were followed for 2 years, and 2/3 of the warts disappeared without doing a thing. So maybe we should just leave them alone, though there are cases that may warrant treatment. Otherwise, we can just let our own body take care of them. Warts are caused by wart viruses, and so spontaneous wart disappearance is assumed to be an immune response, where our body finally wakes up and takes notice. This assumption is based on studies like this, where foreign proteins were injected into the wart itself, like a measles, mumps, rubella vaccine, straight into the wart, which, compared to placebo, appeared to accelerate the immune clearance process. The problem, of course, is that injections hurt, and 30% of the kids that got their warts injected with the vaccine suffered a flu-like syndrome. Yikes. OK, scratch that. What else do we got? Within a few months, any placebo treatment will work in about 1/4 of the cases, so if you put duct tape on 100 warts and 23 go away, that wouldn't mean much. The traditional medical therapies, acid treatments and freezing treatments, bumps the cure rate up to around 50%. So, if you were really serious about testing the efficacy of duct tape, you would pit it head-to-head against one of those, and that's exactly what happened. The efficacy of duct tape versus cryotherapy in the treatment of the common wart. Cryotherapy is one of the treatment of choices for many pediatricians. Objective: to determine if application of duct tape is as effective as cryotherapy in the treatment of common warts. Patients were randomized to receive either liquid nitrogen applied to each wart or duct tape occlusion. When I heard about treating warts with duct tape, I had this image where they were trying to rip them off or something. No. They're just applying a little circle of duct tape every week or so. Here are the details. Although there have been a few anecdotal reports of using tape, no prospective randomized controlled trial had yet been performed until this study, which found that the duct tape was not only equal to, but exceeded the efficacy of cryotherapy, which worked in 60% of the cases, but 85% of the duct tape patients were cured, significantly more effective than cryotherapy for treatment of the common wart, more effective and fewer side effects. The only adverse effect observed in the duct tape group during our study was a small, minimal amount of local irritation and redness, whereas cryotherapy hurts. You want to hear the saddest thing? One young child actually vomited in fear of pain before each cryotherapy session. They were torching the poor kid. Cryotherapy can cause pain and bloody blisters that can get infected and mess up your nail bed. So, duct tape. More effective, fewer side effects, and more convenient. Compare applying a little duct tape at home to making multiple clinic visits, dragging the poor kid back every 2 weeks. It's like a win-win-win. Duct tape can now be offered as a non-threatening, painless, and inexpensive technique for the treatment of warts in children. How much does a little piece of duct tape cost? It's like a win-win-win-win. But the money you save is the money the doctor loses. There's no way the medical profession is going to just let this go unchallenged. Further studies were performed and failed to show an effect. And so we end up in the medical literature with conclusions like this. Is duct tape effective for treating warts? Bottom line, no. Is duct tape really not effective after all? Or was there some kind of critical design flaw in the follow-up studies? We'll find out next. One of the unusual, innovative, and long-forgotten remedies noted in this dermatology journal was the use of duct tape to cure warts. Finally put to the test. There's all sorts of conventional therapies, from acid to cryotherapy to lasers, but most of these are expensive or painful or both, whereas the simple application of duct tape is neither, and may even be more effective than trying to freeze the warts off. Some doctors lauded the study, noting that they've been using duct tape for decades as a painless yet effective treatment. As opposed to surgery and other destructive therapies, the only downside being your patients may think you're off your rocker. But hey, when it works, they appreciate your wise choice to minimize discomfort. Other doctors were not so amused. Here they are spending money on all this fancy equipment, and then along comes duct tape? Studies like that could damage the reputation of cryosurgery, complaining that the 10-second application of liquid nitrogen they used in the study was too short, so it was an unfair comparison. And evidently you really got to get in there and freeze until they get a blistering reaction, and yes, it hurts, but too bad, even making light of the poor child who vomited out of fear of the pain prior to each freezing by making some joke about it. Did they have a point, though, about the 10 seconds? Well, in the duct tape versus cryotherapy trial, those 10-second cryotherapy treatments worked 60% of the time, which is actually better than results of most cryotherapy studies that only seem to cure about 50%. In fact, the typical cryotherapy for warts works so poorly that statistically it didn't even beat out placebo, so all that pain may be for nothing, though aggressive cryotherapy does seem to work better. See, what they should have done, wrote another doctor in response to the duct tape trial, is take a scalpel to it and then really blister it up. And then you go back a week later and try to cut and crater it out, and then maybe go back a third time, bragging that they can get closer to a 90% cure rate. Yeah, but at what cost? In the duct tape trial, one patient lost a study wart in a trampoline toe amputation accident. Hey, there's a treatment that works 100% effective, right? Amputation, right? But at what cost? 85% of the duct tape patients were cured with no pain or tissue damage, whereas aggressive cryotherapy may require lidocaine injection nerve blocks to take the cry out of cryotherapy, and can cause permanent tissue damage. You can end up with these big necrotic frostbite lesions. In one sense, tissue damage, that's the whole point of freezing warts, but you can end up causing these deep burns or end up rupturing tendons, which can cause permanent disability or cause extensive scarring in rare cases. Just the psychological stress of having to keep going back for this painful procedure may ironically impair our ability to fight off the wart viruses in the first place. And so even if the effectiveness of duct tape is shown to be merely equivalent to that of cryotherapy, it would be better, and it was shown to be even more effective. In fact, maybe most effective compared to 10 other wart treatments. Duct tape beat out them all in terms of effectiveness and also in terms of cost, cheaper than all but the DN option, which stands for do nothing. Compared the most effective prescription treatments available, OTC duct tape, meaning over-the-counter duct tape, is 10 times cheaper. It's an unusual and welcome event in healthcare when a common ailment is proven equally amenable to an inexpensive, tolerable, and safe alternative therapy. But wait. If you look at the latest Cochrane review, which is like the gold standard of evidence-based reviews, they acknowledge that cryotherapy is less convenient, more painful, more expensive, but while in the earlier review they did get excited about the effectiveness of duct tape, in 2 subsequent studies duct tape seemed to totally flop. So should we give up on duct tape for warts, or is there another side of the story? We'll find out in the thrilling conclusion next. In 1978, a new approach for the treatment of warts was described, complete with compelling before and after pictures. What was it? The application of adhesive tape. This was put to the test head-to-head in a trial of duct tape versus cryotherapy, to resounding success. Now, though this was a randomized controlled study, it wasn't a double-blind study. Patients in the duct tape group were instructed to remove all tape prior to making a return visit, so the nurses measuring the wart changes wouldn't be biased one way or the other. But remember, look, cryotherapy can cause redness, skin discoloration, crusting, and blisters, so the nurses may have had an idea which kid was in which group, and maybe that could have biased them. So, ideally, there would be a double-blind randomized controlled trial of duct tape for the treatment of common warts, and here we go. Check it out. This is how they disguised the duct tape so no one knew who was in each group. They used transparent duct tape applied to the underside of moleskin, which is an opaque adhesive pad, and the control group just got the moleskin without the duct tape underneath. So on the outside, both treatments looked the same, but half the warts were exposed to duct tape and the other half were not. So if there was something special about the duct tape adhesive, the duct tape group would triumph, and the straight moleskin group would fail. If there was nothing special about duct tape, and the remarkable success of that other study was just the act of covering up warts with anything sticky, then they both would triumph. But instead, they both failed. They both did no better than placebo. The first double-blind controlled trial investigating duct tape for warts, and it failed for treating common warts in adults. Well, maybe that was the problem? The subjects in the original duct tape study were mostly kids, average age 9, whereas in this study the average age was 54. And yeah, warts in younger populations may be more amenable to treatment, so is it possible the reason duct tape worked in the first study, but not the second, is that the duct tape only works in kids but not adults? Well, you'd have to repeat the same kind of study, but this time with children. About 100 school children were randomized, having duct tape applied to the wart or a corn pad around the wart as a placebo, so they both did something, but only one had duct tape on the warts. They used that same clear duct tape so they wouldn't recognize it. It looks nicer, too. 6 weeks later, and the duct tape failed. And that's where the medical community left it. If you look at recent reviews on whether it's better to burn them, freeze them, or duct tape them, they dismiss duct tape as totally ineffective, which is totally understandable, right? No matter how good some original results are, if you put the same thing to the test in a bigger, better study and can't replicate the results, then you have to assume that the first study was just a fluke. But did they put the same thing to the test? Maybe adults wasn't the operative word here, and instead it was transparent. Clear duct tape is not duct tape. It turns out clear duct tape and moleskin both contain an acrylic-based adhesive, where standard silver duct tape contains a totally different rubber-based adhesive. It's likely that the success of traditional duct tape is associated with the adhesive that comes in direct contact with the wart during treatment. In fact, even more likely after the 2 clear tape studies came out, showing that indeed it appears to be something unique in duct tape, and not merely the act of occlusion, not just covering it up doesn't do it. And indeed, the latest addition to the body of evidence found that similar 80% versus 60% duct tape over cryotherapy using real duct tape, but in this case sticking on with some superglue so the duct tape would stick better. In conclusion, odd as it may sound, duct tape is a legitimate and often effective treatment for common warts. The main purpose of cooking vegetables is to make them more edible, palatable, and digestible. The downside, though, is that cooking may adversely affect the levels of nutrients, especially the heat-sensitive and water-soluble ones. But even if you boil greens for 10 minutes, the drop in antioxidant capacity, for example, which is a rough proxy for phytonutrient retention, isn't that much. Yes, there's a significant drop in each case, a 15 to 20% drop, but most of the antioxidant power is retained, even if you boil lettuce for 10 minutes. The single nutrient that drops the most is probably vitamin C, but as you can see, collards start out so vitamin C-packed that even collard greens boiled for 10 minutes have twice as much vitamin C compared to even raw broccoli. You can see the vitamin C in spinach really takes a hit. Even just blanching for 5 minutes can cut vitamin C levels more than half, with more than 90% dissolving away into the water after 15 minutes. Though most of the beta-carotene, which is fat-soluble, tends to stay in the leaves. But just keeping it in a regular plastic bag like you get in the produce aisle can protect it. The refrigeration is important, though. Even in a bag, a hot day can wipe out nearly 50%. Not as bad as drying, though, which can wipe out up to 90% of the vitamin C, suggesting that something like kale chips may pale in comparison to fresh, though vitamin C is particularly sensitive. Other nutrients like beta-carotene are less affected across the board. Cooking by microwaving and steaming preserves the nutrition more than boiling, here measured in watercress. Little steaming or microwaving hardly has any effect compared to raw, though boiling even 2 minutes may cut antioxidant levels nearly in half. Watercress is a cruciferous vegetable, though a cabbage and broccoli family vegetable, so it's prized for its glucosinolate content, which turns into that magical cabbage compound sulforaphane. What does cooking do to it? Well, fresh is best, but steaming's not bad, with microwaving coming in second, and then stir-frying and boiling at the bottom of the barrel. The glucosinolates in other cruciferous vegetables are also significantly affected by boiling. The researchers conclude that red cabbage is best consumed fresh, and look, not just in salads. As I talked about in How Not to Die, I always keep a red or purple cabbage in my crisper to cruciferize my meals, slicing off shreds and putting it on basically anything. But if you are going to cook it, steaming may be the best bet so as to retain the optimum benefits of the health-promoting compounds. Other nutrients we look to greens for are the eyesight-preserving nutrients like lutein, which I've talked about before, and folate, particularly important for women of childbearing age, and vegetables are the main natural source. It's been estimated that approximately half the folate is lost during cooking, which may be true for boiling broccoli, or stir-frying spinach, or mustard greens. But the folate in stir-fried kale holds up better, only losing about a quarter, similar to steamed broccoli florets. But note that broccoli starts out so high that even boiled broccoli has more folate than raw spinach. But check out broccoli leaves. Not only do they start out with among the highest levels, the levels actually go up a bit when you cook them. No one's ever looked at the folate concentration in broccoli leaves, which ironically are commonly just cut off and thrown away, yet contributes great concentrations of this vitamin. Therefore, we should make sure to eat them. Note they also compared thinly sliced kale to kale just torn into larger pieces to determine if a larger surface area of exposure would promote greater losses of folate in kale. However, no effects were found, so slice away. Here they just looked at stir-frying. What about the effects of other cooking methods on kale? There's lots of studies on cooking cabbage and broccoli. However, very little information has been available on the queen of greens until now. First of all, fresh versus frozen. The freezing process is generally regarded as destructive to antioxidant compounds. One just assumes that frozen would have a lower antioxidant capacity compared to fresh. But kale breaks all the rules. The frozen kale showed a higher antioxidant capacity than fresh, and not just by a little, we're talking 60% more. Wow. OK, so what happens when you cook it? If you start out normalizing the starting levels at 100%, blanching and steaming actually boost the antioxidant content, whereas microwaving or even boiling doesn't seem to do much. So you can boil kale without losing out on its antioxidant punch. I told you kale was a rule breaker. But check out that blanching and steaming. Heat can disrupt the plant cell walls and all the little subcellular compartments and spill out extra antioxidant compounds that may have been hiding. Now that's usually counterbalanced by losses caused by high temperatures, but the kale compounds are looking pretty cruciferous and stood their ground.